Good morning, students. In the previous session, we had seen the definitions of basic connectives, truth table, tautology and contradiction. Today's session, let us solve problems based on these concepts. The first example is regarding expressing the following compound proposition in word. That is, they have given the proposition P, Q and R. You need to express these following compound proposition in terms of words. So here they've just told to express in compound proposition. So no need to find the truth values of these. We are not worried with the truth values of this. So compound proposition is what? It is a combination of one or more proposition. That means P and Q. Here P and Q is a compound proposition. So compound proposition can be using any logical connectivities. So let us start doing the problem. So first question is regarding P and negation of Q. P and negation of Q. So what is the statement? Question P, as it is we are writing P is a circle is a conic, Q root 5 is a real number. So write as it is. P is nothing but a circle is conic, and we have and over there, so write and. What is the definition for Q? Root 5 is a real number, but since negation is over there, so what it will be? Root 5 is not a real number. Root 5 is not a real number. So here not because it is negation Q, and because this logical connective. So the complete compound proposition or compound statement will be a circle is conic. This is as it is as P, and this is nothing but the negation Q, and then this is replaced with this notation. So we can see in the previous example, P is a circle is conic, Q is root 5 is a real number. So as it is I have written over here P and negation Q. Second one is regarding negation P or Q. Second statement is negation P or Q. So what it will be? Negation P means a circle is not conic. Negation P means not. What is not negation? Where you are placing appropriate not in a proposition. A circle is not conic, and the symbol this is nothing but disjunction, so it is nothing but or. A circle is not conic or Q. What is Q? Root 5 is a real number. Root 5 is a real number. So this is regarding the second statement. What is the third question? Third question is P exclusive disjunction. That is P exclusive disjunction negation of Q. So what is P as it is? How will you write exclusive disjunction over here? It is either or case, but not both. So it will be nothing but either a circle is conic, either a circle is conic, and you need to write or. Either a circle is conic or negation of Q. What is negation of Q? Root 5 is not a real number. Not a real number, but not both. This is how we are going to write the exclusive disjunction. I had already told regarding this in the example, so you can refer those in definition section also. Next one is regarding Q conditional negation of P. So what is Q conditional negation of P? When it is conditional, it is always if then. So if Q, then negation of P. So what is if Q? If root 5 is a real number, if root 5 is a real number, then a negation P. What is negation P? P is just a circle is conic. Negation P will be a circle is not conic. Then a circle is not conic. Then a circle is not conic. So this is how we are going to write Q conditional negation P. Next two problems are left. Let us solve those. Next, fifth one is regarding Fifth one is regarding P conditional, Q exclusive or R. So what it will be? It primarily this is if and then it is exclusive or. So you should write in terms of if then within that you should write in terms of exclusive or. So what is if then? First is conditional. What is conditional? If P. What is if P? If P is nothing but if a circle is conic, if a circle is conic, if a circle is conic, that is just this section I wrote, then this section, what it will be, then now try to write the next statement, that is Q exclusive or R. So then either Q is what, either Q is root 5 is a real number, either root 5 is a real number or either root 5 is a real number or the exponential R. Write the R statement. What is that? Exponential series is convergent. Write R as it is, but what you are missing? It is exclusive or. You wrote either over here, you wrote or over here, then you should write but not both. So this is how you are going to write the fifth expression. What about the next one? Sixth one is negation of P bidirectional Q. So you know the meaning of this. What is the meaning of this? Negation of P conditional Q and Q conditional negation of P. So how you are going to write this? Statement meaning is if a circle is not conic, then root 5 is a real number, and if a root 5 is real number, then a circle is not conic. So write the statement over here. If negation of P. What is negation of P? I'm writing this, okay? Negation of P. What is negation of P? If a circle is not conic, then root 5 is a real number. Okay, I completed this statement. This you have to replace now. What is that? And if root 5 is a real number, then negation P. What is negation P? Then a circle is not conic. So this is how you are going to write the compound propositions for these expressions. I hope it's clear with this example. These examples already we had seen in the definition sections of all the truth tables as well as those definitions. I hope it's clear with the first example. Now let us move to the second example. In the second example, they told to construct the truth table for the following proposition. Okay, so before you solve this compound proposition and you mention the truth tables, you should know the truth tables of negation, conjunction, disjunction, exclusive disjunction, as well as conditional and biconditional. Okay, now let us solve the problems for the example 2. Okay, so example 2 is nothing but in that first one we had P and negation Q. So first let us write as it is. First question was P and negation Q. Second one was negation P or Q. Third one was P conditional negation Q. Fourth one was negation P exclusive or negation Q. So here let us solve. First we'll write in terms of P and Q. So you know the value of P. So what is the value of 1 second? So what is the value of P and Q? Right as it is. What is the value of P? 0. possible value is 0, 0, 1, 1. Q will be 0, 1, 0, 1. So this you already know, to replace the values of this. Then you just, what all required in all the terms, you have negation Q, negation P. So just write negation P, right as it is, negation P, then negation Q. So what is negation P? Exact opposite of P. So if P is 0, negation of P will be 1. If P is 0, negation will be 1, negation of P. If it is 1, it will be 0, and if it is 1, it will be 0. Negation of Q is nothing but 1, 0, 1, 0. So this is negation of Q. Can just please put a line over here. No confusion between those. Okay. Next is regarding negation of Q. Next, what terms we need actually? Let us solve the first one. P and negation of Q. So what is P and negation Q? These two you have to look. When conjunction is true only when both are 1. So anywhere you have both, only in the third row it is 1. Rest 0, 1 will give 0, 0, 0 will give 0, 1, 1 will give you 1, 1, 0 will give you 0. So 0, 1 is, first term will be 0, second one is also 0, third one is 1, and fourth one will be also 0. So this is P and negation of Q. Next is negation P or Q. So negation P or Q. So what will happen for negation P or Q? Negation P is 1 or Q. Negation P or Q. So you know in disjunction, only when it is 0, 0 it is 0. Rest all the cases it is 1. So just see negation P or Q. Negation P or Q. 1, 0 is 1, 1, 1, 1 is 1, 0, 0 is 0, 1, 0 is 1. So you know in the disjunction when both are 0, the truth value of P or Q also will be 0. So negation P is here, Q is here. So just do 1 or 0. 1 or 0 will always give you 1. 1, 1 also will give you 1. 0, 0 will give you 0. And 1, 0 also will give you 1. So this is the value of negation P or Q. Next one is regarding P conditional negation of Q. P conditional negation of Q. So what is happening in P conditional negation of Q? You know in P conditional Q, when it is 1, 0, it is 0. 1 conditional 0, it is 0. Rest all the cases it is 1 itself. So P conditional negation of Q. So check here, 0, 1 means it is 1 itself. 0, 0 it's also 1 itself. 1, 1 means 1 itself. 1 and 0 will always give you 1 and 0 will always give you 0. So just write 0 over here. Rest all the places you just fill it with 1. So this is P conditional negation of Q. Next is negation of P exclusive or negation of Q. So what is this? Either true or false, but not both. That means when it is 1, 0 and 0, 1, it is 1. Rest both the cases it is 0. So just see for negation P and negation Q. Here both are 1. Here both are 0. Only it is possible in this one. So just write here. This will be 0. This is 1. This is 1. This is 0. So this is how we are going to construct the truth table for the example 2. I hope it's clear with how to construct the truth table for this. Okay. Now let us go to the next example. Example 3. Let P and Q be the primitive statements for which the conditional P conditional Q is false. What does it mean? P conditional Q is false means the value of P is 1, the value of Q is 0. So 1 conditional 0 always gives you false. So you know the value of P and Q. P is 1, Q is 0. Remember it. P is 1 and Q. Now they have told to determine the truth value of this expression. Following expression. So you need to determine the truth value of this following expression. So just will write over here. Insert page. Okay. So they have given that P conditional Q is false. False means it is false. Meaning is nothing but P is equal to 1, Q is equal to 0. Value of P is 1 and Q is 0. Then they have told that to find the truth value of the following expression, that is P and Q. First one. What will be the P and Q? It is nothing but the truth value corresponds, the truth value of P and Q is 1 and 0. So it is, the truth value is 0. You just need to write the truth value of P and Q is 0. Okay, everywhere you need to write the truth value of P and Q is 0. Similarly, Second problem is regarding negation of P or Q. So what is the value of P? 1. P is 1. Negation of that will be 0 or Q. 0 or 0. So you know 0 or 0 is always 0. So the truth value, I'll repeat itself. The truth value of negation of P or Q is also 0. Okay. The third one is regarding Q conditional P. Q conditional P. Now what is Q conditional P? Q is 0, conditional 1. So that is, you know, conditional is only 1 conditional 0 is 0. Rest all the cases it is positive itself. That means it's 1 itself. So this value is 1. So therefore you should write the truth value of Q conditional P is 1. Okay, the next one is regarding, fourth one is regarding negation of Q, conditional negation of P. So what is negation of Q? It is 1. What is negation of P? It is 0. So what will be the truth value of negation of Q, conditional negation of P? So you know 1 conditional 0 is always 0. So truth value is 0. So this is regarding the example 3. They are told to find the truth value of P and Q, negation P or Q conditional P, and then they are told regarding the negation Q conditional negation P. So this is regarding the example 3. Now let us see regarding the example 4. Over here they have given the values of PQR. You need to find the truth value of the compound propositions of the following expression. So let us solve. So we know the value of PQR. P is nothing but P is 0, Q is 0 and R is 1. This has already been given. So based on the question you need to find the compound proposition of first one, P or Q or R. First one was this, P or Q. Just replace the value. What will be the value? 1, sorry, P value is 0, right? 1 second, we just erase this section. First one is P or Q or R. So this value will be nothing but P value is 0, 0 or 0 or 1. So you know that 0 or 0 is always 0 itself in disjunction. This or 1. So this will be 1. So then you need to write the truth value same way how you wrote in the previous example. The truth value of compound proposition. Truth value of the compound proposition. The truth value of the proposition you can write. The truth value of the proposition is 1. So this is regarding the first one. Okay. Proposition is 1. The truth value of the proposition is 1. Second one is P and Q and R. So this is nothing but P and Q and R. So over here you can write in terms of 0 and 0 and 1. So you know in AND operation 0 and 0 is always 0 because only 1 and 1 will give you 1. So this is 0. So 0 and 1 is also 0. So what will be the truth value? The truth value also will be, the truth value is 0. So this is regarding the second compound proposition. Third one is P and Q conditional R. So you need to write what is P value, 0 and 0 conditional 1. So you know that 0 and 0 is 0. So 0 conditional 1 is always 1. So just write in terms of statements. The truth value of P and Q conditional R is 1. P and Q conditional R is 1. So you need to write in such a way. Okay. I have written in the first two examples. So you continue to write in the third also. Fourth one is P conditional Q and R. So what is P conditional? P value is 0, conditional Q and R, that is 0 and 1. You know the output of this is again 0. So what is 0 conditional 0? It is always 1. So write over there the truth value, same way you write over here, the truth value of P conditional Q and R is 1. So this is regarding the fourth. Next, two more we have. Let us solve in the next page. That is fifth one. P and R conditional. Sorry, R conditional Q. So what is the value of P? You know the value of P is 0. R is 1. P is 0. R is 1. 1 conditional 0. You know that 1 conditional 0 is 0 itself. This is 0. So 0 and 0 will always give you 0. So therefore, the truth you need to write. Okay. You need to write the statement. Please remember the truth value of P and R conditional Q is 0. Next is sixth one. P conditional Q conditional negation of R. P conditional Q conditional negation of R. Over here P value is 0, you know, conditional. Next problem is regarding constructing the truth table for the following compound proposition. So let us start with the problem. So the first question was P and Q conditional negation of R. The second question is Q and negation of R conditional P. So this is our second question. So let us construct the required truth table. So this has three terms. So we'll write P, Q, R. Since we have three terms over there, we need to we need to involve 8 binary terms. Okay, so we'll just write over here. Okay, so just write over here possible values is 8 binary values. So 40, 1, 2, 3, 40 followed by 4, 1. Okay, that will be for the P. For Q it will be 2 zeros, 2 ones, 2 0, 2 ones. Can extend this particular line. Okay. Next it is, what are the terms we have here? Okay, here again 0 1, 0 1, 0 1 and 0 1. Next, what are the terms we require in both? It is negation of R. So what will be the negation of R? Just write negation of R. So it will be 0 means 1, 1 means 0, again 1 0, 1 0, 1 0, 0 1, 1 0, 0 1. Yeah. Next, what are the terms we have over here? First, let us solve first one. P and Q. What is P and 1 second, just a minute. P and Q. So what is P and Q? Conjunction is true only when both things are true. So here you can see 1 1 1 1. Rest all the cases you don't have anywhere 1 1. So write 6 zeros followed by last two you may write it as 1. Rest all the values will be 0. So here also it will be 0. Here also 0 0. 1 2 3 4 5 6. So 0. This is P and Q. Next we'll solve the first part. P and Q conditional negation R. So what it will be? P and Q conditional R. So P and Q is here conditional of this. That means conditional to this 0 conditional 1 0. So you know that in conditional only one conditional 0 is 0. Rest all the cases it is 1. So here you check 1 1 is fine. It is 1 itself. One conditional. This will be 0. Rest all the values will be 1 itself. So write 1 1 1 3 1 4 5 6 7. So you have written here 1, 2, 3, 4, 5, 6, 7, 1. So this is the corresponding value. Next it is, we need negation R condition. Solve this. Negation R conditional P. So write as it is over here. Negation R conditional P. So what is negation R is over here, that conditional to this P. So what it is? 1, 0. Check where 1, 0 is there. So first one is 1, 0. Second one is 1, 0. Rest all it is not there. Rest all it is like 1, 1. So only in the first and third case it is 1, 0. Rest all it is okay. That is negation R conditional this, okay. Entire column conditional this. So 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 1, again 0, 1. So you know in conditional, if it is 1, 0, then it is 0. Rest all the cases it is 1 itself. So 1, 0 means 1. 1, 0 means 1. Next 0, 0. So this is, sorry, 1, 0 means 0. Sorry, 1, 0 means 1, 0 means 1, 0 means 0. 1, 0 means 0. Next it will be 1. Okay, 0, 0 is 1. Again here it will be 0. Rest all the cases it is 1. So 4 ones, 1, 2, 3, 4. Okay, so this is negation R conditional P. Remember, in conditional P, one conditional 0 will always be 0. Rest all it is 1. Now we'll write this question as it is over there. So that is nothing but Q and negation of R conditional P. Q and negation of R conditional P. So what is Q and negation of R? So you just need to do and with this operation, that is this and this, this and this. So what is that? Check where you have 1, 1. You have 2 1 1s. Okay, so it will be nothing but Q and R, right? So Q and R, it will be, first one you check 0, 0, so it will be 0 itself. Second one you just check 0, 1, so it will be again 0 itself. Third one you check 1, 0, so it will be 0 itself. Fourth one you check, it is 1, 1, that is fourth one is this 1 and this one 1. Fifth one you check 0, 1, 0, 1 again 1, 1, 1, 1, so it is 0, 0, 1, 1. So this is how we are going to construct the truth table. So this is regarding the example 5. Now let us go to the example 6. Now these concepts are based on the tautology and the contradiction. So you know, in tautology at the end all the values should be true. In contradiction at the end all the values should be false. So that is regarding the tautology and the contradiction. If you get all the values as 1, then it is a tautology. If you get all the values as 0, then it is a contradiction. So here they will solve here itself. Here they are told that prove that for any proposition P, the compound proposition P or negation P is tautology. That means it is all the values are true, and then compound proposition of P and negation P is a contradiction. So here we involve just one value, one proposition, that P. So the possible values will be 0 and 1, and negation P is what? Nothing but 1 and 0, opposite of P. So negation of 0 is 1, negation of 1 is 0. So I wrote here, I'll try to solve here itself. Okay. P and negation. Now next is regarding, we need to solve P or negation of P. So what is P or negation of P? You know that when both the cases in disjunction, when both zeros, the truth value will be 0. Rest all the cases it will be 1. So here we got 1, 1. Next is regarding the P and negation of P. So in P and negation of P, I am doing the AND operation. So you know in AND operator, when both are true, you will get the truth value. So here it is 0. So you can see these values are nothing but the contradiction, and these values are nothing but the tautology. So this is how you are going to solve the, when it comes in terms of tautology and the contradiction in terms of truth table. Okay, so this is example 6. Now let us solve the example 7. Show that the truth values of the following compound proposition are independent of the truth values of their component. So here you need to show that the following is nothing but both the problems are tautology. Independent means both, finally at both the columns you should get 1, 1, 1, 1. That is what it is meaning. Show that the truth value of the following compound proposition are independent of the truth values of their component is nothing but, at the end you need to get all the 1 itself. So that is regarding the this problem. So let us solve this problem. Example 7. So let us solve it in a new page. First one we'll solve, okay? P and P. So let us solve the first one. P and P conditional Q. Okay. P and P conditional Q. Okay, I'll just put a bracket over here. Okay, P and P. So this is a flower bracket. Okay, P and P conditional. Okay, so this is nothing but there is this one. Okay. So first problem, flower bracket. Then we had P and P conditional Q, and with this within this bracket. Okay, now let us solve. So the propositions involved are only two. So we'll just write PQ. Values is nothing but 0, 0, 1, 1. Here it will be 0, 1, 0, 1. So what are the things we have over here? Let us solve first within the bracket. So we'll solve P conditional Q. You know P conditional Q is false only when it is in terms of 1, 0. So this will be 0. Rest all it will be 1, 1. So we solve P conditional. Now we'll solve P and P conditional Q. P and P conditional Q. That is this section. That is with the terms of this. So you know in AND operation only when both are 1 then it is true. So just write that value will be true. Rest all you know it is false. So just write 3 zeros followed by 1. So this is regarding P and P conditional Q. Now this entire thing conditional Q. So that means this and this, that is this conditional Q. So check here, 0 0 is in conditional, 0 conditional 0 is 1, 0 conditional 1 is 1, 0 conditional 0 is 1, 1 conditional 1 is 1. So all four values will be 1. Finally this is proved to be a tautology. So this is regarding the first problem. Let us solve the second one in that, in the example 7. So the second one was P conditional Q bidirectional negation of P or Q. Okay, so let us solve this first. So we'll write P as it is again, P, Q. What all the things we require? First left hand side is P conditional Q. Then we require negation P. We require negation P. Then we require negation P or Q. Okay, so P, Q. Okay, over here P, Q. Let's write the value of 0, 0, 1, 1, 0, 1, 0, 1. So what is P conditional Q? Only for the third one it is 0, rest it will be 1. What is negation P? It is 1, 1 and 0, 1, 1 and 0, 0. So negation P or Q. What is negation P or Q? When both the values are 0, it is negation P or Q. It is 1, 0, 1, 1. When both the values are 0, it is 0. So it is 1, 1 and this value is also 1 itself. So negation P. Now it is bidirectional. That means P conditional Q bidirectional negation of P or Q. So you know in this case we know that when both are 0 it is 1 and when both are 1 it is 1, because we had solved this in the definition. You had seen that meaning of that is nothing but P conditional bidirectional Q is nothing but P conditional Q and Q conditional P. So if you remember the truth table, when both are 0 it is 1 and both are 1 it is 1. Now just do between these two. You do the check for bidirectional between these. So when both are 1, you can see both are 1, both are 1, then both are 0, both are 1. So the values will be 1, 1, 1. So this is regarding the example 7 and it is a tautology. Okay. it is a tautology. So now let us see the example 8. Prove that for any proposition P and Q, the compound proposition is a tautology. The compound proposition is a tautology. So let us solve this problem. So this also involves only two propositions. So we'll write the question over here. That is square bracket, second square bracket, with negation of Q and P conditional Q, square bracket, conditional negation of P. Okay, let us solve this particular problem. So it will be we just involve two terms. So it is P Q. So P is nothing but, we know the value is 0 0 1 1. This Q value will be 0 1 0 1 0 1 0 1. Now P conditional Q. P conditional Q will be, what will be the P conditional Q? All ones, but when it is 1 0 it will be 0. So write as it is, P conditional Q. And also you need a negation Q over here. So we'll just write negation Q also for safety. So it will be 1 0 1 0 1 0. Next it is and between these two. So just write negation Q and P conditional Q, and between these two. So and between these two, you know, when it is only 1 1 it is true. So first term will be 1, rest all it will be 0. Finally this entire, let us consider this in short, I'll write it as R. Okay, just for simplicity I cannot write over here. So just I'm considering this to be R. So R conditional negation of P. Okay, I did not write negation of P, I'll write negation of P over here. Okay, what is negation of P? So negation of P is nothing but 1 1 1 1 0 0. So R conditional negation of P, that is nothing but this term conditional this. So what is 1 conditional 1? 1 itself. What is 0 conditional 1? 1 itself. What is 0 conditional 0? It is also 1. And what is 0 conditional 0? This is also 1. So this is regarding the example 8. Now let us solve the last problem in this section, where it involves 3 terms and it is also said to prove that it is a tautology. Okay. Question is flower bracket P conditional Q conditional R conditional P conditional Q conditional P conditional R. So I repeat, P conditional Q conditional R conditional P conditional Q conditional P conditional R is a tautology. Is a tautology. So we'll write the 3 terms over here. P Q R. Then what are the things we need over here? We need P conditional Q, we need P conditional R, then we need Q conditional R. Okay, then we need Q conditional R, then again we need this section, right? That is P conditional, that is P conditional Q conditional R. We wrote this. Then finally we need P conditional Q conditional P conditional R. And finally nothing but we need the expression, entire question expression, right? So I'll that term I'll take it as S, okay, because no space over here, so I'll just take it, that entire term to be S. Finally we are combining this entire term and writing over here, so I'll take it as S, that is nothing but this. Okay, so I wrote PQR, P conditional Q, whatever the required things I wrote, P conditional R, Q conditional R, first section, that is this section I have written over here, second section I have written over here. Okay, now we will just place the values over here. Okay, 1 2 3 4 5 6 7 and the 8. Okay, we'll place the value 0 0 0 0 1 1 1 1. When it is 3 times, 0 0 1 1 0 0 1 1, then 0 1 0 1 0 1 0 1. Okay, now what is P conditional Q? You know that P conditional Q, check for 1 0. So these two values is 0. So it will be, these both values are 0. Rest all the cases it is 1 1 1 1. Next it is P conditional R. P conditional R, it will be check for 1 0 for between these. Okay, check for 1 zeros over here. You have over here and you have in the last. So here you put it as 0 and one more is over here. So you put it as 0. Rest all the cases it is 1 itself. Sorry. P conditional R, right? It is P conditional R. Sorry, here you have to put it 0 and here you have to put it 0. I have written here. Just place this one. Okay, so we'll start. Okay, so here rest all the cases, you know, it is 1 0 conditional. This is also 1, this is also 1, this is also 1, this is 0, this is 1, this is 1. So this is how you wrote. Next is Q conditional R. Check between these two. Check between these two. So Q conditional R, your third term it is 0 1 0. Then again over here it is 0. Agree? Then fill it with 1. 1. P conditional Q conditional R. Where is Q? This is Q conditional R. This term and this. That means, I mean, this P conditional Q conditional R. So check where you will get 1 0 is only one case, I guess. In one case you will get it as, no, one case you will get it as 0. That is 1 0. Here you will get it as 0. Rest all it is 1 1 1 1 1 1 1 1. Next is P conditional Q conditional P conditional R. P conditional Q conditional P conditional R. I mean P conditional Q conditional P conditional R. This conditional this. So what is where you have 1 0. Again you have over here. Again you have over here. Only this section is 0. Rest all it is 1. So write as it is over here. Sorry, but it is not there at the last time. Okay, as it is, you just need to write. Finally, it is between conditional between these two. That is what I have expressed as S. That is what is our question. So what is in the conditional, you know, when it is both 1, it is 1 itself, and when both 0 also, it is 1. So finally all the values will be true itself, 1 itself. And this is all, we'll get it as tautology. So this is the problem. Thank you.